All right, so let's go ahead and turn in your green folder to page 8, okay, where it says investigation 1.2 mixing juice, comparing ratios. So I want you to do a little warm up before we start. I want you to read each of these sentences and then decide whether you think it's a part to part or a part to whole comparison. Okay, so let's just go ahead and start with number 1. So do you think in taste tests, people preferred Bolda Cola outnumbered those who preferred Cola Nola by a ratio of um, 3 to 2? Do you think that's a part to part or a part to whole? Okay, well, let's kind of look at a little picture of this. So if I had 3 people liking Bolda Cola to every 2 people that like Cola Nola, it sounds like this is a part to part because these are each of the 2 pieces. It's not the whole. It's not like the people together. So that's what you said, part to part for this one. Okay, next is the ratio of boys to girls in our class is 12 boys to 15 girls. Is that a part to part or a part to whole? Okay, let's go ahead and take a little picture of this. This means for every 12 boys, there are 15 girls. Okay, it's not like these numbers are like a combination of these things together. So this is, again, another part to part. Okay. All right, let's look at number 3. 3 says the ratio of boys to students in our class is 12 boys to 27 students. Oh, I think I can use the same Post-it note. So now I've got 12 boys, and then to get 27 students, I'm going to say that my total then is 27 if I add the 12 and the 15 together. Okay, so this is a part to a whole, the whole group. Okay, students is our whole. Okay, the ratio of kittens to felines in our neighborhood is 1 to 4. Okay, well, do you know what a feline is? Feline is just any kind of cat, including kittens. All right, so if I look at that, here would be my cat to total felines. Okay, so kitten is considered a feline. So to have a ratio of 1 to 4, I'd have to have 1 kitten and then 3 cats. So that would be a part to the whole group. Okay, felines are considered the total. Okay, 2/5 of our class has blue eyes. Okay, so let's say our class has 15 kids in it. Okay, and 2/5. So if I kind of divide this into 5 groups and do 2/5 have blue eyes. So it could be maybe like this. Let's see, these are all blue eyes. Okay. Is 2/5 a part to part or a part to whole? Well, the 2 represents the 2 groups and then the 5 is our total class. Okay, so the 2/5. So the fifth isn't, it's not like 2 to 3. Okay, so it's 2 out of 5. So this is another part to whole. Okay, a paint mixture calls for 5 pints of blue to every 2 pints of yellow paint. Okay, so let's see, how's a picture of this. So if I'm going to try and mix this together, I'm going to take, 5 pints. 5 pints of blue and 2 pints of yellow and mix that together. Well, the 5 pints of blue is a part, 2 pints of yellow is also a part. So the whole would be that mixture. So this is another part to part. Okay, Bill answered 82% of the questions correctly on his last science quiz. Okay, so 82% means 82. He could have gotten it would be like getting 82 out of 100. Now, maybe there weren't actually 100 questions. Maybe it was 41 out of 50 or something. But what is this representing? So the 82 would be what he got correct. The 100 would be out of the entire test. So this is another. So percents are often part to whole. Okay, so a lot of times when we use either fractions or percents, that's often a part to whole comparison. Okay, now we can do it with a ratio, but often we'll state like students, like you state the group, and that's how you can see it's a part to whole. Okay, let's look at our question for today. So every year, the grade 7 students at Langston Hughes School go on an outdoor education camping trip. During a week-long trip, the students study nature and participate in recreational activities. Everyone pitches in to help with cooking and cleanup. This year, Arvin and Mariah were in charge of making orange juice for the campers. They plan to make the juice by mixing water and frozen orange juice concentrate. To find the mix that would taste the best, they decided to test some mixes. Okay, so we've got a couple different mixes that we were going to try and use. Okay, so and then the recipes over here. Mix A would be a combination of 2 cups of like the concentrate. Okay, so like the orange stuff to 3 cups of water. Mix B, we're going to put 5 cups of concentrate and then mix it with 9 cups of water. To make C, I'm going to use 1 cup of concentrate and mix it with 3 or 2 cups of water. And to do D, I'm going to mix that with 3 cups of concentrate and 5 cups of water. So which one of those do you think would taste the best? Okay, and which one would taste the least? Okay, so on your paper over here, can you look at these different recipes? And I'll bring these over here kind of so you can see them. And could you say which one you think is going to taste like the least? Okay, orangey, and actually in a minute we're going to use Cokey, like least like Coke. And then on this one, so the greatest or most Coke-like, okay, because I'm going to actually make this mixture out of using water and Coke. So what do you think between here and here would taste the best? So just go ahead and list the letters across here. So which one? This one is going to taste blah, not so good. Okay, so least like Coke, and make this one the best tasting. Okay, so the least watered down. Okay, and then after you put them on here, I'm going to go ahead and actually make these mixtures up, and then I'm going to give it to my son Steve to test it out, see if he can just taste the one that actually tasted the best versus the worst. All right, so I'm going to do the 4 different recipes that the campers came up with, but just so I don't make as much, I'm going to use this for my cup. I know it's smaller than an actual cup, but I'm going to use this as my measuring thing. So I'm going to take 4 different cups. I'm going to label one A, B, C, and D. Okay, and we're going to see how these recipes taste. So for A, I'm going to add 2 cups. I know it's not quite a cup. 2 cups of Coke. Okay. And then 3 cups of water. Okay. So for recipe B, I'm going to add 5 cups of Coke. Okay, 9 cups of water. Okay. Recipe C, I'm going to do 1 cup of Coke, 2 cups of water. Okay, and then just to get a little bit more, I'm going to repeat that. 1 cup of Coke, 2 cups of water. Okay. All right, for D, I'm going to do 3 cups of Coke. 5 cups of water. Okay. I think I'm going to give Steve a little bit more of recipe A, so he can tell us. I'm going to add a little bit more to recipe A, which was 2 cups of Coke. 3 cups of water. Okay, so which one do you think will taste the most Coke-like, and which one will taste the most watered down? So I'm going to give Steve these 4 different cups. He's going to rate them then. Okay, from least to greatest in terms of least, like this one tastes the most watered down, to greatest, this one tastes the best, the most Coke-ish. So let's go ahead and see.
Okay. It's not very good.
Just wait a minute. I'm doing a video, you guys. Sorry. Okay, so you think this one tastes the most watered down?
Yeah.
This one tastes the most like Coke-ish.
Yeah.
Okay, so I'm going to write the letters down that he put, and then we're going to see. So he thinks C tasted the worst. You think recipe B. Okay, and then recipe D. And then you thought the one that tasted the best was recipe
A.
A. Are you sure now?
Yeah.
A tastes the best. Okay, kind of looking at it, it does look like the most normal color. Okay, so we're gonna do some math and see, test Steve out from, and again, here's what we've got. So he thinks this recipe was the most watered down was C. The least watered down he thought tasted best was A. So we're gonna do some math and see how well the taste tester he was. Okay, so there are lots of different ways to kind of compare these recipes. So remember, recipe C was 1 cup of concentrate or Coke to 2 cups of water. Recipe B was 5 cups of Coke to 9 cups of water. Recipe D was 3 cups of Coke to 5 cups of water. And recipe A was 2 cups of Coke to 3 cups of water. Okay, so we could do a scaling. Okay, so we could do scaling maybe, and we could just maybe test some of Steve's by scaling. Like how many times as much water was there than Coke in recipe 1? So if I take 2 and divide by 1, there's twice as much water as there was Coke in there. But if I do 3 divided by 2, that's just going to be 1.5 times as much. So we could think about scaling. So this was like kind of times 1.5. Okay, so, and over here on C, okay, so this is like twice as much Coke, huh? Or twice as much water. All right, so wouldn't that one taste quite a bit worse than this one? It's got twice as much water in it as the amount of Coke. Okay, well, this one has 1.5. So I think he'd be right on using that for scaling. Okay, we could also have done maybe a part to whole comparison. So and maybe thinking about fractions a little bit. So like this has 1 cup of concentrate to 2 cups of water. So fraction wise, this was like 1/3 of the drink was made out of Coke. And on this one, 5 like out of so doing a part to whole, so 5 out of 14 of the drink was water. For this one, it was 3 out of 8 of it was water. And for this one, or was Coke, sorry. For this one, 2/5 of it was Coke. So we could figure out what fraction the drink was Coke. So 1/3 of the whole um, liquid, okay, was Coke. This one, 5/14, 3/8, and 2/5. Okay, so again, these fractions are a little hard to compare. Is this the smallest fraction? So the least amount of that. Okay, or what could we do with these fractions? We could either get like common denominators to try and compare. I wonder if percents would be easier. So let's try and see what percent each of the drink was Coke. So if I do 1 divided by 3, that gives me 0.3, and then I make that out of 100. So out of 100, this would be about 33%. Okay, if I made this one out of 100, okay, so I take 100 divided by 14 times my 5 and scale that up. This gives me, it's about 36% of it was Coke. And now maybe this might be a good way to kind of compare. Now I'm going to try and make this out of 100. So let's see, 100 divided by 8, scale that up, so times 3. This is like 37.5%. Okay, about 38% Coke. And then how about this out of 100? That one's maybe a little easier to do. So 20. So it looks like this is like out of 40. So 40%. Oh, wow. I think Steve did do a pretty good job of taste testing this. So 33% Coke versus 40% Coke, although it's still pretty nasty tasting. That one should have tasted better than this one. Okay. But all the percentages were fairly close.